Okay, colleagues, I think my job is to set the scene for the details going to follow. So this is a fairly broad overview, which means that I'm going to limit what I say to a few, what I think are the real issues, all connected with, obviously, the application of new technologies to manufacturing. And the first thing, of course, to say is we're not starting from here. Technology has been around for a long time in manufacturing. You can see some of them appearing on the screen at the moment. Most of them came from the Industrial Revolution, and we've been progressing ever since, getting more and more sophisticated technology until we've got production lines, assembly lines now, which are almost all automated. And we've really culminated in what are now fairly intelligent robots and manufacturing systems. Now, each generation is built on the last, but also builds on new technology and advances in science. So what one tends to find is that countries that are good at science and technology generally have more advanced manufacturing. But obviously, manufacturing equipment now is getting expensive, so you need a sound economy with which to buy the technology to give you a sound economy, which is one of those awful kind of vicious circles one can get into. Now, the first wave of robots were largely experimental, and they often tried to mimic human beings in terms of look and feel, and they were not very successful. The second, which is really the current generation, are more functional, usually based around a single function, and usually are now our co-workers. They're assistive, so they work with human beings to help them take out the weight and the danger of certain tasks. And so rather than replace humans, they often are used to co-work. Now, the next generation, the third generation, is likely to be much more disruptive, because we're now bringing in, well, what's called artificial intelligence. We're not really sure what that means, but machine learning certainly to take over more of the skills of the human workforce. So we're going to see fairly skilled human work replaced by more intelligent robots. What we're going to see is advances in things like predictive maintenance, quality control, more reliable design. So we'll see big changes in the industry over the next decade or so. The problem is, of course, that what this needs is, first of all, leaders who are aware of the art of the possible, know what can be achieved, have the vision to apply it to their own organisation, and then commit to the implementation and deployment of these technologies. We need better support for startups who have the impetus and the flexibility to develop new technologies and improve combinations of existing technologies. And we need workers with the skills to work alongside these new intelligent robots, to support it or them, to monitor them, to maintain them. So unless we have those three components in place, we're not likely to have effective manufacturing of the next generation. So why now, I suppose, is the question. Why is technology poised to revolutionise manufacturing? Well, what we've got is the intersection of a number of technologies which are together creating what has become known as manufacturing 4.0, 4.0. Some of these are specifically aimed at manufacturing, others are not. And what we've got firstly is Internet of Things, right? The connection, the networking of billions of physical devices and the ability to share data between them. The trouble is the Internet of Things will come to some of their problems, but they are going to revolutionise. The fact that there are so many things connected and capable will revolutionise what we can do. 5G, the next communication generation, will permit faster, more reliable networking and is needed to connect to the Internet of Things. And there are some things we can do tomorrow that just can't be done today without 5G. Things like autonomous driving, for example, requires lots and lots of data to be sent over networks very quickly, instantaneously, in fact. We've got what's called smart manufacturing or digital manufacturing. So tools and equipment that are highly programmable can be networked together to form complete processes and systems. Highly connected with the Internet of Things is sensors everywhere. We've got so many types of sensor now, we can kind of read everything in an environment, everything in a process, We can fit these sensors to products and process steps, so we can monitor how things are made and when things go wrong. Should improve quality, should improve response and repair times for any faults. We've got tools for manufacturing design and development and for simulation of manufacturing processes. So we can actually design a virtual factory, test it in a simulation, see what works, what doesn't, what needs tweaking, where the delays are, where the bottlenecks are, and we can tweak the design in a simulation before we start to build the physical line. As we've already said, we've got more advanced robots which are becoming more adaptable and can start to think and act autonomously. Perhaps the greatest thing of all is we've got manufacturing informatics. All those sensors, all those devices connected together means we can see what's happening, therefore we can tune things more accurately, more reliably. So we've got metrology, non-destructive testing, and we're getting much more effective quality assurance and automated inspection. There are people now, aeroplane manufacturers, using drones to take a tour of an aeroplane to look for cracks in the wings and so forth. So simple technologies can be used very effectively to do things that are difficult or expensive now. And as I've already said, what we need are leaders who are aware of these technologies and can also be aware of the potential for connecting them together. And the problem is, we've already said, connected devices give us rise to things like the possibility of cyber attack. And the problem with people putting sensors into devices and to have connected Internet of Things is they forget that these things can connect to much more substantial, much more sophisticated systems. So the device itself may be under no threat, but it might provide a cyber attack to a big system. So your doorbell now that can see who's at your door may not be a threat in itself, but when it gives access to your home servers, you can see that there's a greater potential for threat. We've got lots and lots and lots of data, masses of data being transmitted around by these systems, and we have to analyze and present that data into rich information. Luckily, I suppose, the rise of data matched by the rise of devices to handle what's called big data. And big data gives us a way, so the devices that handle big data gives us new ways of analyzing data that we couldn't do before. I thought the biggest example of big data that I heard about was the way Google Translate set up. What they did was they took the proceedings of the Canadian Parliament, which are in French and English, and just fed these into a massive database. And then they used algorithms to go around searching for common words, the most frequent words, and then they used the English definition of that frequent word to work out what the definition of the equivalent French word was from the same proceedings. And they slowly built algorithms that could develop thousands, that could take in thousands and thousands and millions, in effect, of words and work out what the meanings were. So they didn't tell Google Translate what these words meant. Google Translate worked it out by looking at the English version, comparing it to the French version, and deducing what the French word meant. And they've since done that in several languages, of course. So big data is a big asset when you've got large volumes of data to analyze. There are concerns not only about cyber attack, but about surveillance and privacy. Wider society needs to be aware of the implications of this rise in connected devices, needs to debate these issues and agree ways forward to control and regulate the use of data. The EU has been taking a lead in this, really, with the GDPR regulations, and other countries are now following to realise that you need to control, or at least be aware of, what's happening to all your data that's being collected by various devices. There's a great need for standards so that these things can really interconnect. Anybody who's tried home automation with devices that are claimed to be connected to Google Home or HomeKit or Alexa knows that unless they work together to the same common standards, they're almost impossible to connect. And you can't build a manufacturing system out of non-interconnectable devices, clearly. So there's a great potential for change if we can get leaders who are on top of the game and can see that this can be positive to create more reliable, highly productive manufacturing systems. But there are always buts, aren't there? There is the greatest danger that organisations will do what they've always done with automation, which is to automate what they currently do badly now. So if you've got bad systems and you automate them, you end up with bad systems moving faster, which means you create more errors, or you create your errors faster, create your problems faster. So you have to have good, effective systems designed from the start before you start automating them. So firms have to design effective, efficient systems that can benefit from the technology and use it productively without the downsides that we've talked about. We need manufacturing systems and process engineers who both understand the systems and the technology. Technology nerds who know technology are no use unless they understand manufacturing and systems and how systems go together. Now, besides creating these systems, we are going to create new kinds of companies, or we may well do. So how will manufacturing companies change? How will it be different in the new company, the new normal of manufacturing from the old? Well, first of all, they should have the same mission, these companies, but have a different vision of where they're going and how they're going to get there using technology. So the overall aim doesn't change, but the way in which we reach that aim certainly does. Companies should become more innovative, not by creating new technologies, but by finding new ways of adopting and combining technologies which already has. And there are lots of technologies that can combine into new or improved processes. You can see some of the more recent technologies, and you can see how these change what we do. Again, one of my favourite stories is sheep farmers in Australia and New Zealand, where they've got massive farms, used to spend a fortune riding the bounds of the farm, checking on fences, repairing breaks in the fences. And for cattle, this is even worse because cattle can bring down fences more easily. So what they do now, rather than build fences, they put GPS devices on their cattle and they build kind of virtual fences on a map, on a screen, so that when the cow moves outside that kind of virtual boundary, doesn't know it's doing it, doesn't see it obviously, but it just gets a tiny electric shock and turns back. There are no fences to build, no fences to maintain, it's all done with technology. People have the wit to see how these technologies can be used in all sorts of new ways. Now, these technologies can also change the structure and organisation of a company. They can change the ability to do things like centralisation or decentralisation. Neither one is better than the other. Both suit certain tasks, certain companies, certain types of leader. But the leader can now use the technology to devise and design their structure rather than letting the technology or the system design it. We can get new ways of managing and supervising the workforce, new ways of measuring and monitoring performance, new ways of training and mentoring employees. So there are all sorts of ways in which technology can work, and it can create or it can accelerate change. But it only moves forward if we know what we want to do and know the directions we want to move, and we know those are beneficial to the company, to the society in which we operate, to our employees. So we need all stakeholders involved in the decisions that change our organisation using technology. The successful firms, the game changers if you like, will be those that have spent part of this last few months of lockdown thinking about these issues, thinking about how technology can help them and how it can keep their employees engaged and motivated as they move to their new vision. We've seen employees working from home. It works well if you can keep them engaged and motivated. You give them tasks to do, but unless you engage them in what the company's doing, why it's doing it, and so forth, then you're not going to get a really forward-looking company. Thank you.